Hey guys, this is Mr. E coming back at you with simple and compound interest. And so we learned this today on Monday, February 27th, 2017. We did do problems number 1 and 2 in class, but I wanted to go ahead and do them again. That way you can see them again, and if your parents or your older brother or sister is there helping you, they can see it as well. So number 1 says, David invests $10,000 in a savings account that pays 3.5% simple interest. And all of these problems on this sheet, it's going to tell you whether you need to do simple interest or whether you need to do compound interest. Like, for example, on number 2 here, it says we earn interest compounded annually. So you would do the compound interest formula. Okay? And you have 2 different formulas. One of these formulas is going to be I equals PRT. And that formula looks like this right here. Okay? And what this stands for is the interest, okay, the simple interest equals the principal times the interest rate times the time in years. Okay? And this is your cutout that you got today in class. And on the back of it, it tells you what everything stands for. Okay? And so principal is the amount of money that we start out with. The rate of interest, okay, is the percentage, but we write that as a decimal. So you can either move the decimal 2 places to the left, or you can divide by 100. So for example, if I wanted to know 5% as a decimal, okay, I would take the decimal spot and either move it 1, 2 like this for 0.05, or I could take 5 in my calculator and I could divide it by 100, and that would give me 0.05. So 5% as a decimal would be 0.05, and so this is how we would use it in the formula. Okay? And then T, of course, stands for the time in years, and it's extremely important that your time is in years. So for example, if it gave you 36 months, you would have to convert that to 3 years, and T would equal 3. So please be very careful when you're doing with the time. Make sure that it's in years. Okay? And so that is simple interest. Then we also have compound interest, okay, and this is a different formula, but all of these letters mean the same things as they did previously. The P is still the principal, R is still the interest rate, and T, once again, is the time in years, except now this is an exponent, okay, and so that's very important. You understand it's an exponent, okay, a little bit different than the simple interest formula. Also, A is going to be the total amount of money calculated on the original principal and any previously earned interest. Okay, so it's very important that you understand those differences, and you can read through them on your ISN, and you'll also understand them as you do more of these problems. Okay, so we're going to start out with number 1, and we're going to use the simple interest formula because it simply says simple interest right here. And so that formula is I equals PRT. And once again, that's the simple interest equals the principal times the interest rate times the time in years. So what I like to do is I like to write out what all my variables are. So it says David invests $10,000, so that's going to be my principal because that's the amount of money we start out with. So the principal is $10,000. He puts in a savings account that pays 3.5% simple interest. So that percentage, that is our interest rate. So I'm going to take 3.5 and divide it by 100. And that's how I would write my interest rate as a decimal. So I'm going to come over here and I'm going to write R. My interest rate is 0.035. Okay, and then I have T, which is the time in years, and it says if David makes no withdrawals or deposits to the account, how much will be in the account after 7 years? So T equals 7 years. Okay, so now I'm going to write out my formula. I equals my principal, which is 10,000. Times my rate, which is 0.035, times the time of 7 years. Okay, and so I'm going to come in my calculator. I'm going to go 10,000 times 0.035 times 7. And so I get that my interest earned or accrued is $2,450. So essentially what happened here, David brings $10,000 to the bank. He puts it in the bank account. The bank pays him this much interest over 7 years. David doesn't touch the money. Notice how he makes no withdrawals or no deposits to the account. He doesn't touch the money for 7 years, and when he comes back, this is how much interest he's earned. But the question says is how much will be in the account? Well, David deposited $10,000. Right here, he deposited or he invested $10,000, and he earned $2,450 in interest. So the total amount in his bank account is going to be $12,450. Okay? Very, very important that you understand what the question is asking you. Okay? Because this formula here only tells you the interest. To get the total in the account, you have to take the interest and add back the principal. Okay? Because that $10,000 didn't just disappear. That's how much money you started with. So therefore, that money is in the account, including the interest you earned since you didn't touch the money for 7 years. And when you come back in 7 years, your bank account will look like this. Moving on to number 2. Number 2 says Garrison deposited $500 in an account that pays 3%. Garrison deposited $500 in an account that earns 5% annual interest compounded annually. If he makes no withdrawals or deposits, how much interest will the account earn after 4 years? So this is compound interest. I'm going to use my formula. A equals P, parentheses, 1 plus R to the T power. Okay, now remember, P, R, and T still represent the same things. So for example, here, my principal is $500 because that's how much he deposited. My interest is going to be 5%, which we know as a decimal is 0.05. And T, my time, is 4 years. Okay, so I'm going to plug these values into my formula. A equals 500, because that's P, parentheses, 1 plus 0.05 to the 4th power. Okay, because remember, T here is an exponent. Okay, and so when I go on my calculator, I'm going to go 500, parenthesis 1 plus 0.05, close parenthesis, and I'm going to click this little arrow here. I'm going to go to the 4th power. Okay, and so I get $607.75 because money we would round down, and money only goes to cents. It doesn't go to the thousands place. So I'd go $607.75. Okay, so A, though, remember, is the total amount of money in the bank account, including the principal and the interest. This says how much interest will the account earn after 4 years. Well, if this is the total, and you put in 500, then the interest you accrued is going to be $107.75. Because you put in 500, you ended up with $607.75, so you earned $107.75 in interest. It's very important to understand exactly what these two formulas give you because they are both different. One is for simple interest, one is for compound interest. The simple interest formula gives you the interest. So if you want the total in the account, you have to take the interest and add back the principal. Okay? Compound interest gives you the total in the account, so if you want the interest, you have to subtract the principal. Okay, so they're kind of almost like opposites, but then again, they're also for two different situations. But they kind of give you opposite ends of the spectrum. The simple interest formula gives you the interest. The compound interest formula gives you the total, and if you want to find the interest, you have to subtract the principal. Here, if you want to find the total, you have to add the principal. Okay? All right, number 3. Jared invests $10,000 in the savings account that pays 3% simple interest. So we know we're going to use I equals PRT. How many years? So it wants to know the years now. Will it take for the account to grow to $12,700 if he makes no withdrawals or deposits? Well, for the account to grow to $12,700, he started out with $10,000. So to get from $10,000 to $12,700, that's $2,700. And so the interest he needs to earn is $2,700. Okay? The principal we know is 10,000. And we know the interest rate is 3%, or as a decimal, that would be 0.03. Okay, so now I can plug in everything I have. So I know I is 2,700. Okay, I, 2,700, equals P, which is 10,000, times 0.03, which is R, times T, because T stands for the time in years, and that's the question they're asking me, is how many years. So I don't know how many years, so I just put T. In my calculator, I would do 10,000 times 0.03. Okay, and so I get 2,700 equals 300 T. Okay, everybody see where I got this 300? Okay, I did 10,000 times the interest rate. That gave me 300. Now I'm going to take this 300, and what I do to one side, I must do to the other. I'm going to divide both sides by 300, so I can get what T equals. So T equals 9. Okay, so for me to grow my account from 10,000 to 12,700 at 3% simple interest, it would take 9 years with no withdrawals or deposits. Okay, moving forward to number 4. Gilberto invests 10,000, so we know our principal is 10,000, in a savings account that pays 4.75%. 4.75 divided by 100, 0.0475. So my rate, 0.0475. Okay. If Gilberto makes no withdrawals or deposits, how much will be in the account after 7 years? So T is 7. So I'm going to go I equals, we have simple interest, I equals PRT. I'm going to do I equals 10,000 times 0.0475 times 7. So I get my interest is 3,325, but it says how much will be in the account. Well, you put in 10,000, the bank paid you 3,325 in interest. So therefore you should have $13,325, which is answer choice B. Number 5, Tran invests 15,000 into a savings account that pays 4% simple interest. So we know our principal is 15,000. We know our interest is 0.04. Or excuse me, that's our rate. Excuse me, that's R. Okay, and then it says how many years, so we don't know what T is. How many years will it take for the account to double? So we want the account to be 30,000, meaning we want our interest to be 15,000. Because 15,000 and 15,000 would be 30,000, which is doubling the account. Okay, so I'm going to go, my interest is 15,000 equals 15,000 times 0.04 times T. So in my calculator, I'm going to do 15,000 times 0.04. That gives me 600. So I have 15,000 equals 600 T. Now I'm going to divide 15,000 both sides by 600. And I get T equals 25. So to double an account, to make the account balance 30,000, from 15,000 to 30,000 at 4% simple interest, it would take 25 years. Willa deposited 5,000 into an account that pays 6% interest compounded annually. Which expression can be used to find the value of her investment after 5 years? Well, we know this is A equals P parentheses 1 plus R to the T power because it's compound interest, and this is my formula. I know my principal is 5,000. And then we have 1 plus my interest rate of 6% is 0.06. And it's over 5 years to the 5th power. That looks like answer choice A. because 1 plus 0.06 is 1.06. We do it to the 5th power because t is an exponent, and 5,000 is our principal. Moving on. Number 7, Travis invests $25,000 in a savings account that pays 2.75% simple interest. So we know I equals PRT. How much interest does he earn each year? Okay, so we know our principal is $25,000. We know our interest rate is 0.0275. Okay, and we know our time. So it says each year, so we're going to do 1 year. Okay, and so we're going to do I equals 25,000 times 0.0275 times 1. So each year he earns $687.50 in interest. Number 8, Audrey deposited $2,800, so we know that's our principal. It pays 2.65% interest, so 0.0265. Compounded annually, so I know I'm going to do A equals P, 1 plus R to the T power because it's compound interest. What is the total value of the account after 7 years? So A equals my principal of $2,800, parentheses 1 plus 0.0265 to the 7th power. At any point that I go too fast in this video, do feel free to hit the pause button, back it up a little bit, and replay it, because I do go kind of fast. 1 plus 0.0265 to the 7th power. Okay, so the total amount in the account is $3,362.57. We would round this 6 to a 7 because that 5 would round up. Okay, and so it says, what is the total value of the account? Well, this would be the total value. Answer choice B. Okay, if I wanted to find the interest, I would take the total in the account and subtract the principal. And so answer choice A would be the amount of interest that you earned. But the total amount in the account is what you get here. Number 9. Cherise put some money in a savings account that paid 2.7% simple interest. So my rate is 0.027. After a year, the account was worth $7,890.44. So she did simple interest. What was the amount Cherise originally deposited? So we're looking for the principal. And the time was after a year, so time equals 1 year. The account was worth $7,890.44. Okay, so it is simple interest. Once again, it is, like I said, it is simple interest. Okay, so what you've got to do in this case, it gives you the account balance. So each of these, you've got to take them and try them out. Okay, so my formula is I equals PRT, right? And so I'm going to try these different formulas out. Okay, so I'm going to try these different principal amounts out to see which one would yield this number. Okay, so for example, if 7,200 was my principal, I would do 7,200 times, that's my principal, times my rate, 0.027, times 1. Now, whoops, what did I do there? I had 2 multiplication signs, my apologies. So 7,200 times 0.027 times 1. Now, what's going on here? Let's try that again. 7,200 times 0.027 times 1. Okay, so I get 194.40. Now that's the interest, so I need to add that back to the principal. Well, 73.94.40 does not equal 78.90.44. So I know A is not my answer choice. Now I'm going to try letter B. So 76.83 times my interest rate, 0.027 times 1 year, gives me 207.44. I'm going to add back that 76.83. And so that gives me 78.90.44, which is indeed the balance of the account. So that is my answer. Okay, and once again, all I did was I took the answer choice and worked backwards. So I know I gives me the interest, so I had to take the principal, 76.83, and multiply it by my interest rate times the time, which is 1 year. That gave me 207.44, which is my interest, but I have to add that back to the principal to get the total amount the account was worth. Okay, which I did that here. Interest plus principal, total amount the account is worth, which is right there. And finally, last but not least, number 10, Carl used his credit card to buy a 90-inch HD flat screen for $2,600. The credit card company charges 28% compound interest per year. If Carl made no payments for 2 years, how much would he owe the credit card company? All right, so his credit card, he bought the TV for $2,600. We have 28% compound interest, so that is, R is 0.28. Okay, no payments for 2 years. The principal balance was $2,600 on the credit card. So A equals P, parentheses 1 plus R to the T power. So we've got 2,600, parentheses 1 plus 0.28 to the second power. And so basically, you should pay your credit card debt because for a TV that costs $2,600, you would owe $4,259.84. And if I subtract my principal, that means you're paying an extra $1,600. You're paying an extra $1,659.84 for a TV that only costs $2,600. So think twice, kids, before you use that credit card. Make sure that you're able to pay it back in time, and don't put it off for 2 years like this guy, because Carl has just cost himself a lot of money. And so C is my answer choice. That's how much he would owe the credit card company. Hopefully this helped you guys. I know I went a little fast, but hopefully you can see the differences between simple and compound interest. Hopefully you understand that each formula is different and that simple interest gives you the interest. And so if you want the total amount in the account, you have to add back the principal. And hopefully you also understand that compound interest gives you the total amount in the account. So if you want your interest, you have to subtract the principal. Okay? Two different formulas that give you two different things. Okay? Both very, very useful and both very, very easy if you follow the steps that I've given you and you follow your formulas. All right, guys. I'll see you in class tomorrow. Have a nice day.